In this example, we're looking at reflecting it over the line y equals x first, and then translating it. So to reflect it over the line y equals negative x, we're going to switch places with x and y, and also change our signs. So the 0.11 becomes negative 1, negative 1. The 0.32 becomes negative 2, negative 3, and the 0.24 becomes negative 4, negative 2. So that's reflecting it over the line y equals negative x. That's this line here, y equals negative x. Now we're going to translate it. So to translate it, we're just adding our values. In this case, we are translating it, let's see, 2 units to the right and 5 units up. So essentially we're adding 2 to negative 1, we would get positive 1. If we add 5 to negative 1, we'd get positive 4. We're adding 2 and 5 again, so we'd get 0, positive 2, and we're still adding 2 and 5, so we get negative 2, positive 3. So if we graph those points, we have 1, 4, 0, 2, and negative 2, positive 3. So here's our image after the pre-image was both reflected across the line y equals negative x and then translated. Okay, so part of what we're looking at here with these composite transformations is whether the order makes a difference. And so far we've looked at 4 examples where all 4 examples the order was different and we got a different result. The next 2 we're going to look at actually give us 2 transformations where you can do them in either order and it turns out you end up with the same result. So the first transformation on this example is we are rotating 180 degrees. To rotate 180 degrees, we're switching the signs for our x and y coordinates. So the point 1, 1 becomes the point negative 1, negative 1. The point 3, 2 becomes the point negative 3, negative 2. And the point 2, 4 becomes the point negative 2, negative 4. So next, now we've rotated 180 degrees, we're going to reflect it across the x-axis. To reflect across the x-axis, all we need to do is change our y-coordinate. So the point negative 1 is going to become the point negative 1, positive 1. The point negative 3, negative 2 is going to become negative 3, positive 2. And the point negative 2, negative 4 is going to become negative 2, positive 4. So if we look at those points real quick, negative 1, 1, negative 3, 2, and negative 2, positive 4. And if we look to get from this black pre-image to our image, our final result, what we're doing here is just reflecting. This is reflecting over, let's see, across the y-axis. So any point xy becomes the point negative x, y. All that happened was our x-coordinates change their sign. In this example, we're reflecting across the y-axis first, sorry, I misspoke, the x-axis first, and then we're rotating it 180 degrees. So to reflect it across the y-axis, we just need to change our, let me think, our y-coordinates to be negative. So this point 1, 1 becomes the point 1, negative 1. The point 3, 2 becomes the point 3, negative 2. And the point 2, 4 becomes the point 2, negative 4. Next, we're going to rotate this 180 degrees. So to rotate it 180 degrees, we need to switch the signs of our x and y coordinates. So we're not switching places, we're just switching their signs. So the point 1, negative 1 would become the point negative 1, positive 1. We switch places with b, it's going to become negative 3, positive 2, and we're switching the signs for c, it's going to become negative 2, positive 4. So if we look at these real quick, here's our final image, and you'll notice that looks like the last one. To get from our pre-image in black to that image in purple, we are again just reflecting over the line y equals x. Sorry, I said that wrong. Reflecting over the y-axis, so we can write that in coordinate notation. Any point xy becomes the point negative x, positive y. And again, that's what we're doing to get from the first image to the last one. Okay, so we spent some time looking at transformations and composite transformations. Specifically for the quiz or test, hopefully you feel better about how to use these rules about rotation and reflection. Some of the questions you might be asked to find are, asked to do is looking at a picture and identifying how far it's been rotated. So for example, if we start with this picture at the top, up here, then as it's being rotated, we should be able to recognize, okay, this is a 90-degree rotation. As we rotate it, if we start with this figure at the top, we rotate it 180 degrees, it would look like this picture. Or if we rotate it 270 degrees, or we rotate it 300 degrees, sorry, 360 degrees, you should be able to recognize how far it's being rotated. If it helps, you can literally turn it, pick up your piece of paper, your computer, whatever you're looking the image at, and turn it 90 degrees, turn it 180 degrees, turn it 270, and see what it should look like and match it up. Specifically, as you prepare for your unit exam, these are a couple of the key composite transformations that you're going to be expected to need to recognize. The first one is when we reflect over parallel lines. A reflection over parallel lines is the same as translation. The second one on the right is reflecting over intersecting lines, and when you reflect over two lines that intersect, it's the same as a rotation. Double the angle that's between those two lines. So you may want to go back and look at your notes if you have forgotten these two things.